All right, let's talk about software development life cycle, or SDLC as it's called sometimes. What is the SDLC? And some of you who have come from the software world, or maybe not, maybe you've heard of this, but it's the process by which software is defined. And it used to be this waterfall. They call it a waterfall approach. So first you do the requirements, then you do the design, you go and implement it, you go and test it. And then, any sort of bugs or fixes, enhancements, and you go back through the same cycle. So it's, one after the other, and you just keep going through them. And it's shown here in a circle, but it's also known as a waterfall approach. So with cloud computing, that has changed a little bit, changed it a lot. So now instead of, so if I go here, back here, you see there's kind of development, and then this part of it might be known as development, and then there's a piece in here that might be missing, which is the deployment. So development was separate from deployment. So you had software developers, and you had people who were doing operations. And now all of a sudden it's starting to get a little bit more tight-knit, where software developers are working more closely with the operations teams, and they kind of understand a little bit more what each other's doing. Instead of development and operations, you have this thing called Devops, right? And it's a, you can still, you can think about it as, let's say we start here, for example, doing the code, right? So after the code is built, so after you write the code, you go and build it. And there's different tools that you can use for all of these different phases. You're building and you're testing, right? So in the past, it's been discrete. First, I would build, then I would test. So I'd code, I'd build, I'd test. Now they do more of what's called continuous integration. So while I'm coding, if I check code in, it gets built and tested right away using some of these tools. And then when we're ready to release, those same tools are used to release. So the role of a DevOps engineer is to be able to participate in this entire cycle. So now I've released it. So, DevOps engineer, for example, would help set up the environment where you do these integrated tests. And then when it's ready to release, it would release it to a test environment. And then, somebody would test it, and then you'd be released automatically to a production environment. And then, use these different deployment methodologies. You no longer have to do it in your own data center. You now have web services, right? If you're talking about cloud, you have web services. So all your deployment can be automated using all these interfaces to AWS. And you can scale in, scale out using either AWS, using containers. And then we get into this mode of operations, right? How do you make sure things are running consistently, that no changes have been made to nobody's gone in and make changes to the operating system configuration or the application configuration, or if you need to deploy a change to the configuration, how do you do it? Again, lots of tools to be able to do that through APIs and through the interface. And then being able to monitor that everything is up and running. And then again, you get into the planning, coding. So it's just a continuous loop. It's not kind of this discrete set of steps, or distinct, I should say distinct development and operations. Operations getting more involved with development, development getting more involved with operations, being able to do stuff. And the key here is what? What is the key? I don't know if I emphasized enough, but what is the key objective here? It starts with an A. Automation, right? If you look at all of this, the idea is to have it all automated, where I check something in, it builds automatically, it does, tests automatically, it releases to production automatically. You're monitoring it, you're making sure the configuration changes are applied automatically. You want to keep as much human intervention out of this process as possible. Not because humans are dumb, but it's just that humans make a lot of mistakes, and it's better to automate things, check your automation, test that it works, and then just let that automation run over and over and over. So this is what we were talking about just a little bit ago, where we're talking about, somebody had asked what's the advantage, or where do I see Docker, and it's in these kinds of microservices, right? So when I have a single or monolithic architecture for an application, the entire application is built as a single unit, and it goes back and, let's say, accesses the database. When I get to the microservice architecture, now it looks like this. And in fact, you can have layers in this microservice architecture. So this microservice, for example, these two might be allowing you to process payments. These two or these three might be the user interface. And this one might be some middle layer logic. And now I'm able to use these different microservices, containerize those microservices, and scale up and down based on a function or based on a service, rather than based on an entire piece of virtualized hardware. So that's what this is showing. Essentially, you create your applications using microservices, containerize it using Docker. It's run on an EC2 instance, which is itself a virtualized environment, which is running on some hardware in AWS. And I'm not a software developer today, but it's important in the world of DevOps to be able to understand, for example, how to build Docker containers, how to deploy good Docker containers. So that's where you start to get a little bit of understanding of what developers are doing. If they're what kind of web servers they're using, the configuration of those web servers. So all of that will be stuff that you gain over time, experience and understanding you gain over time. But as DevOps engineers, it's important to be able to understand how to build these containers based on the microservices that are being created and how to scale them out. All right, we talked about microservices. This is another concept I think that's important to talk about here, and it's this notion of API, or application programming interface. I'm sure many of you have heard API in different contexts over time. How does it apply to us? Well, how does so first of all, as a user of a particular service, how do I communicate with that service? So if I'm using, let's even say Office 365, how does my user interface connect to Office 365? Well, Office 365 has an API, or application programming interface, that allows it to communicate. But then if I go deeper within any application, if you've got these microservices, how do microservices communicate from one to the other? Well, exactly the same way. You create an API. That API is defined ahead of time. So each microservice knows, it's kind of like a contract. Each microservice knows what the contract is with the other microservices in terms of API. And if it needs to get data, send data, get information, send information, it knows exactly how to do it. And so, the APIs are important to understand at that level. And if you get into DevOps, then certainly implementing APIs in AWS for API Gateway might be part of something that you do.